Okay, before we get into what trig identities are, this is a lesson on where they come from. There's whole sets of different identities. These are the reciprocal identities, which should be fairly obvious. We know that sine u and cosecant u are reciprocals. So it should follow pretty straightforward that sine u equals the reciprocal of cosecant u. And then similarly, you can arrive to all the rest of them. Okay, a quotient identity, tangent u equals sine u over cosine u, or cotangent is the reciprocal, cosine u over sine u. This comes from when we look at a right triangle. This is angle u over here. We normally call this distance x, this distance y. And since we come from the unit circle, we're going to call this r, because in a circle that would be the radius. So now if I look at my sine and cosine, sine of u equals y over r, or if I solve for y, y equals r times sine u. Cosine u equals x over r, or if I solve for x, that equals r times cosine u. Tangent u is your opposite over adjacent, so that's going to be your y over x. And using the substitutions we made up above for y and x, we're going to have r times sine u over r times cosine u. And r divided by r is going to cancel. So I'm going to be left with tangent u equals sine u over cosine u. And then cotangent is the reciprocal of tangent. So if you flip the sine and cosine over and make it cosine sine, you have cotangent. Okay, your Pythagorean identities come from your Pythagorean theorem. Same triangle. We're going to call this u, horizontal x, vertical y, hypotenuse r. And we're going to have the same equations we solved for earlier. Y equals r sine u, and x equals r cosine u. Now if I use my Pythagorean theorem, we know the Pythagorean theorem, a squared plus b squared equals c squared, where a and b are two legs of the triangle and c is a hypotenuse. So in my triangle, I've got x squared plus y squared equals r squared. If I substitute in my x and my r, now I'm going to have, in replace of x, I'm going to put in r sine u, quantity squared. In place of y, I'm going to put r cosine u, quantity squared. And this is still going to equal r squared. Going to distribute that square, r squared. When you square sine, you make it sine squared u plus r squared, same thing over here, cosine squared u equals r squared. Both of these terms have an r squared in common, so I'm going to factor it out and make it r squared times sine squared u plus cosine squared u equals r squared. And then if I take both sides and I divide them by r squared, now I'm going to get sine squared u plus cosine squared u equals 1. So there's how we get the very first one. Keep going to find the next two. If I take that equation, so here's one of our major ones. If I take that same equation and I divide everything by, let's divide by sine squared u. Okay, I've now transformed this into 1 plus. We know that cotangent u was cosine u over sine u. So it's going to follow that cosine squared over sine squared is going to be cotangent squared plus reciprocal of sine, that would be, oh, this is an equal sign. So equals cosecant squared u. So there's another one. And then if I rewrite it one more time, my original, sine squared u plus cosine squared u equals 1. And I divide everything this time by cosine squared u. Now I have sine over cosine is tangent, so sine squared over cosine squared is going to be tangent squared u plus 1 equals secant squared u. And there's your third one. So this is how we come up with everything that was at the top of this page that I can't get to anymore. Okay, cofunction identities. Okay, if I look at a triangle and I call this angle u, horizontal x, vertical y, hypotenuse r. I know that I'm in a right triangle, and so it's easy to find this angle, which would be, there's 180 degrees in a triangle. I've got half of them in my right angle, and so the other half, so I've got 180 total. Take away the 90, now I've just got 90. So this is going to be 90 minus u. Well, most of the time we're in radians, and 90 is pi over 2 minus u would be the equivalent. Now, if I'm looking at cosine u, that's going to equal adjacent over hypotenuse, x over r. If I turn this now and look at sine of pi over 2 minus u, so now I'm going from the other angle, opposite hypotenuse. This is also going to equal x over r. Well, x and r can only have one meaning, so these two are equal to each other. Sine of pi over 2 minus u equals cosine u. And the rest of them are derived very similarly. They're just using different angles of a right triangle. Even and odd identities are a little bit harder to explain because we haven't covered them in class. You may know them from a previous class. But in essence, if a function is even, it means it's reflected over the y-axis, and that means that f of x equals f of negative x. If a function is odd, it's reflected over the x, or over the y-axis, then the x-axis, and it means that f of negative x equals negative f of x. So let's look at sine. Here's a picture of my sine graph. If I continue it over here. Okay, first of all, is it even? Is it reflected over the y-axis? No. Is it odd? Is it reflected over the y and then the x? Well, if I reflect this over the y-axis, do that in blue, reflect that side over to the left, and reflect the right side or left side over to the right. And then if I flip it over the x-axis, now it's going to run straight into the original function. So it is odd, which means that f of negative x equals negative f of x. And what does that mean for us? That means if I take the sine of a negative angle, that's the same as putting my negative out front and taking the sine of just the angle. Let's look at the cosine graph. We know cosine is the bowl on the other side. Even would reflect over the y-axis. Is it reflected over the y-axis? Yes. So cosine is even, which means f of x equals f of negative x, which means to us that cosine x is the same as taking the cosine of a negative angle. So taking the cosine of an angle or the negative angle is still going to give me the same answer. If I look at tangent, is it even? Is it reflected over the y-axis? No. Is it odd? Is it reflected twice? Well, that would mean over the y, and then taking that line and going over the x. So yes. Which means that tangent of a negative angle is the same as the negative answer of tangent x. So that's where those identities come from.